Hey, what is up guys? Welcome back to another video, and in this video we're going to be continuing on with our Swift programming tutorial series, and in this particular tutorial we're going to be taking a look at a much more advanced topic, and this has to do with how Swift manages memory. And this is not only a very important topic for you to know about, and so that way you know exactly how it works, but if you want to do iOS development professionally, this sort of stuff, questions about this sort of stuff, is commonly asked in those interviews. Okay, so it's a very important topic. Now, what exactly is the topic that we're going to cover? Well, it's weak self. Now, what's weak? Well, weak is a keyword in Swift that effectively allows you to create a weak reference to an object. All right. So, weak is generally used to prevent what are called strong reference cycles. But strong reference cycles are also often referred to as retained cycles. And what happens when you have a retained cycle or a strong reference cycle between two objects? Those objects can never have their reference counts within the ARC system, or automatic reference counting system, in Swift, reach 0, which means they will never be deallocated. And when they're never deallocated, that can cause memory leaks. All right. So again, those retained cycles, they occur when two or more objects have strong references to each other, which again means that none of those objects can reach a 0 reference count. Now, if you want to avoid such a situation, generally you're going to want to use weak. We'll take a look later at an example of using weak self to prevent these retained cycles. Now, of course, when we're talking about weak self, the next logical question is, okay, well, in practice, where am I going to use this? Well, one common place you'll find weak being used is for closures. And this is generally used when you want to have a weak reference to self, hence weak self. This is, you commonly find this being used for asynchronous tasks, such as network requests. You'll find this with animations, and then you'll find it with other tasks that might outlive the current scope that you're working with. Now, let's talk a little bit about how memory is actually managed in Swift. I talked a little bit about how that works, but memory is managed in Swift by using what's called reference counting, and the system is called ARC, or automatic reference counting. Right? So, in the ARC system for Swift, an object is deallocated from memory when its reference count is equal to 0. And when you have that weak reference, that allows either object in that reference cycle to go to 0. And once it reaches 0, it's gone from memory. It's deallocated. And of course, I mentioned before, again, I'm going to repeat it to drill it into your head. If there are strong references between two or more objects, they can never be zero. Like, the reference counts can never be zero. And when they're never zero, that creates a memory leak, which is a very bad thing. You never want a memory leak. Okay. Now, of course, that's pretty much all the talking that needs to be done about weak self and how reference counting works and stuff like that. At least on a basic level, it goes way deeper than what I covered here. In the next video, we'll talk about unowned, which is another level of what we're talking about here. And we'll talk about the differences between weak and unowned in the next video as well, but just know they are similar but also different, okay? So let's take a look at an example of where a strong reference is created with self and where there's a weak reference created with self. So in our code, let's see. We're going to create a class. I'm going to call it my class. This is going to have a closure as a property. Okay, so when you create a closure as a property for a class, when you're in this case, that's where these reference cycles can occur when you're trying to capture self in your closure. So var my closure we're gonna have this be a closure that returns void. And make sure this is an optional closure. All right. Now, when you have let's say you have a func do something, and we say self dot my closure equals whatever here. This creates a strong reference to self. But if you were to do, say, self dot my closure equals opening curly brace, and then after that opening curly brace, we have left and right square brackets, and in between those we have weak self. In what this is doing is it's creating a weak reference to self. So now the reference count for self and for the closure can be 0. So when one reaches that count of 0, it can be deallocated from memory, thus avoiding a strong reference cycle and going and avoiding memory leaks. Okay, so that pretty much does it for this video on weak self, and just weak in general, as well as retain cycles and arc. Thank you all so very much for watching, and we'll see you in the next video.